Hello everybody and welcome back. We're looking now at question 5, still on the 2010 Manitoba contest. Question 5 also has 2 parts, just like 4 and 3, and really all the questions we've seen so far. So 5a, the number 64 is both a perfect square and a perfect cube. Find the next positive integer with this property. Okay, that's actually not that bad. So why is 64 both a perfect square and a perfect cube? Okay. 64 can be written both as 8 squared and as 4 cubed. So why does this work? Well, for something to be both a square and a cube as an integer, we can see that how best to write this. K has to be equal to m times the square root of m. But then, yeah, so that's the way we want it. Yeah, we square root both sides. But then that means that m, therefore, root m must be an integer. So m is itself something squared. And that tells me k itself must be a cube. So we must be looking at something to a 6th power, an integer to a 6th power. And indeed, that's what happens with 64. 64 is 2 to the 6th power. So in order to be, I think this is something you would probably have to write, in order to be a square and a cube, it must be a 6th power. So it must be t to the 6th for some integer t. That's sort of what I just proved up here. But I think it's important to actually state that, because then you say, okay, 64 is 2 to the 6th. The next one up should be 3 to the 6th. It's literally the next possible t value I could have. 3 to the 6th, and so that's 81 times 9, so that's 729. And that would be my answer. Excuse me. That would be my answer for 5a. Okay. I don't think it'd be enough just to say 729. I know sometimes when they mark this, they just say, okay, the numeric answers for the first few don't require that much justification. But as you get later in the contest, they really do want justification. So, might as well give it to them the entire time. Okay, 5b. How many solutions of 2x plus 3y equals 763 are there in positive integers x and y? Alright, so we want 2x plus 3y is 763. Okay. Be nice if we had a solution. I think if we let y equal 1, then we need 2x to be 760. Well, that would mean that x is 380. So xy equal 380 and 1 is a solution. Okay, so this is a nice linear, sometimes called a Diophantine equation, or Diophantine equation. And there's a really nice way to go about taking one solution and getting all the solutions for it. Suppose x naught y naught is a solution. So suppose this is a solution. So we know 2x naught plus 3y naught is 763. I can be really sneaky. So 2 and 3, 6 is the lowest common multiple of 2 and 3. And you always use the lowest common multiple in this case. So I can add 6 and subtract 6 without changing the equation. I'm just sort of adding by adding a sneaky 0. Adding in a number and canceling it at the same time. But then I can write 2 x naught plus 3 y naught minus 6. And so from there, x naught plus 3, y naught minus, not 6, not 6, minus 2. is also a solution. Now, well, yes, you should explain how you get new solutions, and from this we're going to be able to get all solutions. I don't exactly think it's necessary to explain why this gives all the solutions. But for those of you who are curious, those of you saying, no, you're not being completely rigorous, let's talk about why this gives all the solutions. And as long as I have one solution, I can get all the other solutions just from this process. Now, suppose for example, I had x naught, y naught, and I also had, say, x naught, let's say it's minus 1 or something like that. We'll call them x1. Yeah, we'll do that. x1, y1 are two solutions. Okay. Then we know x naught, 2x naught plus 3y naught is 763. And we know 2x1 plus 3y1 is 763. So I could subtract the one equation from the other, and I'd get 2x naught minus y1 plus 3y naught minus y1 is equal to 0. And then I can say, okay, 2x naught minus y1 is negative 3, or I guess we'll just say 3. 3y1 minus y naught. I brought one over to the other side. Now, all of these are integers. Therefore, x naught minus x1 is a multiple of 3. And y1 minus y naught is a multiple of 2. Okay? So the closest we could ever have x naught and x1 would be if they differed by 3. Well, here's a solution that differs by 3. Here's a solution that differs by 2. Okay? And this forms the basis of an argument that you really do get everything this way. If you want to really get into it, I guess saying, well, x1, suppose x1 were closer than x naught minus 3. Then you'd have, x1 must be x naught minus 1 or something like that, but that isn't divisible by 3 and that sort of thing. So, ultimately what I'm going to conclude is from 380 and 1 as a solution, we can get all other solutions. All other positive integer solutions. Now, we can't subtract 2 from y. So that would go to 383 and negative 1. Now, this is a solution. It really is. But it's not one we count because y is less than 0. Okay. What if we go backwards? So 377, and then we add 2 to get 3 here. Well, yeah, that's a solution. And we can keep going. Add 2 again. Subtract 3. Add 2. And we can keep going. We can keep on going. Okay? Now, how many times can we do this? Well, the number of solutions is going to be 380 divided by 3. And then I think we want the floor function of that. Right? How many times can I subtract 3 from here? So if I called the number of solutions n, 3 times n, I subtract that off of 380, that would still need to be positive. 1 solution, 2 solutions. Oh no, I guess we need to be able to subtract that off of 383. Okay? So, I guess we can, so we'll call the number of solutions n. And 383 minus 3n needs to be positive. Otherwise, we'd have a negative number here for the x, and obviously a positive odd integer for y. For example, 763 and 0. This is a solution. Right? No, not 763. We need to multiply it by 763 isn't a multiple of 3. Interesting. So 3 times. So what's the closest multiple of 3 here? 762. But 762. So we'd have to subtract off an even number. So subtract 4. So 2 and 759 divided by 3, 25. 253. That's going to be the last of those solutions. Anyway, we'll have 383 is greater than 3n. The closest multiple of 3 below 383 is 381. So 3n is 381, and so n is going to be 127. Yeah, 127. And yeah, there we go. So it's going to be, therefore there are 127 solutions. Okay. Another way we can see that is the pattern in the y's, and we know the last y. So y is always, if we number our solutions, solution k is 1, this is 2, this is k is 3, k is 4. Y is always 2k minus 1. And 253 is 2 times 127 minus 1. And x is always 383 minus 3k. Okay. So 127 solutions, and that was the last part to this question, right? Yep, that's 5b. So onward we go to question number 6. I'll see you guys for that in the next video.